Hello. This is a little guide on using Dolphin Memory Engine and the RAM Search in Memory Engine to find particular values for custom Robo modding. So first open up the game, then open Memory Engine. If it's not already hooked down here, under Dolphin, click Hook, and then turn on Auto Hook for future uses. Then under View, click Memory Viewer. So I'll go through some examples of searching for values. First, I'll get into a battle. And let's try to find player one's health. The way we do any sort of searching is with this top half of the Memory Engine window. We can specify a type of value that we're searching for and how it relates to some value that we type in here. So we don't know exactly what the health value would be stored as. But if you think max value is 1,000, a half word's max value is like 65,000, I think. So a good start might be to look for something that is a half word that has a decimal value of 1,000. So let's do a first scan. And there's not too many results found, which is nice. Sometimes there can be hundreds of thousands of results, and you have to do some clever strategies to whittle it down. But right now we just have 181. So to make sure we're looking at the right thing, let's deal some damage to player one. And did any of these change? We can do decreased. So after we did our first scan, we have this set of values that Dolphin Memory Engine is holding on to. We can do subsequent scans and look for particular changes in this value. So let's do a decreased, next scan, those are results, okay. So then presumably health is not stored as a half word, starting with a value of 1,000. So let's try some other options. Let's just look for a word with unknown initial value. Give it a scan. Now, you'll notice in the memory viewer, there's some values that are changing, and there's a lot of values throughout the memory that just sort of constantly update. Like for instance, the camera rotation, robo position as you're moving around, a lot of like frame counters and values used for RNG. So what we can also do is search for values that are unchanged. We know that the Robo's health isn't changing, so if we just do a couple unchanged searches, we'll see the value goes down a little bit. It's not decreasing that much, so let's go ahead and deal some damage and look for something that's decreased. Okay, nice, 662, that's quite a few less. Let's do it again. A couple unchanged scans, then another decreased. Okay, so now we only have 5 results. But these look way too high to be 697. Let's take a look at a couple of these. And copy the address and throw it into this. This doesn't look quite right. Let's look at the next one. Now this looks like it could be a floating point value. A floating point number is just a way of representing decimals in a very concise format. You don't need to know exactly how floats work, but the gist of it is that they will take up 4 bytes, and the values will look absolutely massive if you're just looking at them in decimal. So let's take this value, copy it, and put it into this float converter. Oh, look at this. So this float value in hex corresponds to this decimal value, 697.7 some. If you look at Robo 1's health, it's 697. So what we can do is double click this address to add a watch, update the type to float. You can see now that there's this 697 value showing here. So watches basically just let you hold on to a particular value in memory and constantly look at what the value is. So I'll do some more damage. You see it's updating, and it lines pretty well to the health value shown on screen. And if you think a little bit about how damage is calculated in custom Robo, it makes sense that it would be a decimal. There's multipliers on the Robo in terms of damage dealt and damage taken. And also, if a Robo is down, there's another multiplier for that. So it would make sense that damage would be tracked more precisely than just in integers, hence using floats. Okay, so we've got the red Robo's HP. Let's now try looking for the red Robo's down, because I know how much down Sniper does. Sniper does 800 down. Let's reset the scan. Okay, so Ray, this is vanilla that I'm in, so Ray has 1000 down. Let's think, how might the game calculate down? Well, one option is that there's a second value somewhere in memory, just like the health, which goes down as a Robo takes down. So let's try the first strategy that we tried for health again, where we start with 1000 in decimal and shoot Ray and see if it goes down. Decreased. Shoot. Next scan. Nothing again. Okay. So maybe it's not starting at 1000. Okay. So we're starting at some unknown initial value. We do a scan. We shoot Ray. I'll pause here. And we know that the value, we're guessing that the down has decreased. Then as we resume the game, it should continually increase. Okay, I'll watch the pip once the third pip comes back. Okay, I'm not going to do any more scans. So these values are all still increasing, but at this point, Ray probably has full down. So it seems like none of these are actually raised down. So let's try another strategy. We'll start again with unknown initial value, do a scan. Shoot Ray, pause. Let's see if there's anything that's increasing. Do a scan, and then maybe it'll decrease as the down regens. Decrease, next scan, next scan, next scan. Okay, he's got his last down pip back. Okay. Let's do it again. Shoot Ray. Increased. Decreased. Okay, and we're left with two values here. So let's see what happens on the frame where Ray gets hit. Bam, right there he gets hit. Oh. And this value is set to 800, which is how much down Sniper does. And if we go to the next frame, it goes down by 1 each frame. And we watch this value, speed it up for a sec. As it gets closer and closer to 0, you see that Ray's down has refilled. So it looks like one or both of these is Ray's down. Now I know that the red Robo's player struct is at 8024E120. Starting here is where all the data related to the red Robo is. I think it's pretty reasonable that this value, which is just a little bit after 8024E120, is probably the red Robo's down. So I will go ahead and write that down. And that's pretty much how using RAM search to find values works. You have to do some guesswork, some guessing into how the game might do particular things, trying different things in terms of the data type you're looking for, whether something might be increasing or decreasing, whether or not you know the initial value. But the main strategy is just trying to find something in the game that you can easily control, and if possible, know the exact value of at a given point in time.